Hey, fourth grade friends. We are back in my house now after a couple episodes of being away in the classroom. This is going to be another math video. What we're going to do is we are going to be looking at the next page in your math packet. And we are looking at Frankie's Fairground. This is a two-page packet, page 1 and 2, and I want to look specifically at its pages 119 and 120. Since I'm back home, I've got my norms again. Quick reminder, during this time we're going to have a positive attitude, we're going to be respectful, we're going to keep trying even when things are hard, and we're going to remember the word yet. And what I want to show you today is it's a little bit of a review and a little new stuff, but we're going to go over how we can estimate before we use a multiplication or division equation to solve a story problem. And you're going to be looking at some of these story problems on these two pages, and they're all asking for equations and estimations. So I wanted to walk through what that could look like, giving you a different story problem that's going to look similar to the story problems that you're seeing when you're doing this packet. So we have our character, Frankie, and they are at the fair, and they are looking at the rides at the fair, and they're seeing all these math problems coming around while they're at the fair. So here's one that I came up with that I want to give you, and I'm going to show you the same steps that you should use as you're solving these problems. Oops, sorry, dropped my marker. So Frankie is looking at a roller coaster. And the roller coaster sits on a rectangular frame that has an area of 162 square yards. And one dimension of that rectangle is 9 yards. What is the other dimension? So that's what we're trying to find out. So let's start. We can do a quick drawing. I know that my area of my rectangle, like I said, is 162 yards. It's area, it's yards squared, and I know one dimension is 9 yards. You'll notice I'm including my units. We talked about that in our last video as well. Make sure you got your units on there. And I'm trying to figure out what this dimension is going to be. So I need to do two things before I jump into solving this. I need to make an estimation, and I also need to set up an equation. So I'll start with an equation. I know that my area, like we've talked about before, is the height times the base. But in this situation, I've got the area and I've got one dimension. So I can use division instead to solve what this is going to be. Remember, division and multiplication are related. If this length times this length gives me my area, then I can use my area and divide by this length to figure out what this length is going to be. So I'm going to set up that equation first. I'm going to write down 162 divided by 9 equals, and then I'm going to write a D after that equals sign. 162 divided by 9 equals D, and that D is going to stand for dimension. I'm trying to find what this dimension is right here. Remember, we can use letters when we're trying to figure out an unknown. So now that I've got that set up, I also need to think about what I'm going to do for my estimation. And I know that 9 times whatever this dimension is will get me 162. So I'm just going to think about some of my 9's facts real fast. One of the places I always start is with my 10's facts. So I'm thinking, okay, well, 9 times 10 is 90. Kind of ran out of room. And 90 times 2 is going to give me 180. I'm doubling 90 right there. And 180 is pretty close to 162. So I can think, well, if I've got 180 and I got that by doing 90 times 2 or 9 times 10 times 2, so think of that as 90 times 20, that's going to get me pretty close. So, but it's not going to get me exactly there. So for my estimate, I'm going to say, well, 19. That'll get me pretty close. I've got 9 groups of 19. Now, from there, as usual, there's a couple different strategies. Let me write my equation again. At the top, we're trying to solve 162 divided by 9 equals D. Now, some of you are thinking, all right, well, I can draw 9 groups. 2, 3, 4, 5, 6, 7, 8, 9, and then I'm going to put a dot in each, and I'm going to keep doing that until I count up to 162, and that'll get me my answer. That totally is a way you can solve it, although I would challenge you to try and use some multiplication as well instead. So I'm going to go back to what I was thinking about earlier, where I said, I know that 9 times 20 equals 180. And so I'm looking at 180, and I know that's bigger than 162, but, well, I can start subtracting groups of 9 until I get to 162. So I can go 180. I'll subtract 9 from that. That's going to be, oh, it's close, but it's still not actually quite there. It's 171. So I'll subtract another group of 9. 171 minus 9. And that's going to get 162. So if I started with 20 groups, and then I subtract 20 groups of 9, excuse me. I started with 20 groups of 9, and then I subtracted one group of 9 here, one group of 9 here. I'm letting you think through it. How many groups do I have altogether? I've got, I'm out of room. I've got 18 groups. So that would be my answer. My other dimension would be 18. And that's a strategy that I really like to solve, using multiplication to help me solve a bigger division problem like that. Now, the other thing I want to talk about real fast is looking at the bottom of page 120. And this is question number 4. It says to write and solve an equation for each of the problems below, use the table to help. And it's got a table. It has kilometers, meters, decimeters, and centimeters. So going across the top row, there's 1 kilometer, and then it's showing that 1 kilometer is equal to 1,000 meters, which is equal to 10,000 decimeters, which is equal to 100,000 centimeters. And you can use all of those as a really nice way to solve, looking at the different measurements using those different units. Sorry, I kind of lost my train of thought right there. But looking at the different units. So like A asks, how many centimeters are there in 45 meters? And I want to give you a quick reminder about something we've used a lot this year, is a ratio table. So if I have centimeters and meters, A asks how many centimeters are in 45 meters, well, what I could do is I could set up a ratio table. And on one side I'll have my meters, and on the other side I'll have my centimeters. So I'm looking at my table and I know, okay, it's 1 meter to every 100 centimeters. So set up our ratio table. We got meters on this side, centimeters on this side. So if I have 1 meter, and that equals 100 centimeters, and some of you are already seeing where I'm going with this. If I've got 45 meters, how many centimeters am I going to have? And I'll remind you, we can use ratio tables to solve by looking at what happened from one number to another, going vertically, and then doing the same thing on the other side. So if I go from 1 to 45, we want to think about this with multiplication for the most part. I could find that we multiplied by 45 on this side. So if I multiply by 45 on this side, get my times in there, yep, that will give me my answer. I'm not going to do that math for you. But that's a really good way that you can be using ratio tables in there. And you might think to yourself, well, I'm not really using an equation for that, but you totally are. You're using those multiplication equations. You're just writing them on the side of your ratio table. All right, fourth grade friends, hope that was helpful. Good luck with your work this week. Don't forget, you can take a picture of your work once you're done. And if you have any questions about what you're supposed to be doing, please let Ms. Schaefer or myself know. Have a good one.